Second lesson on surds today. So can you make sure you've got this down in your books? First thing is to simplify each of these. So if you could just pause the video for a couple of moments here and give the students 2 minutes or so to try and simplify those. Write them in the form A root B. Once you've done that, you should find that they all simplify. So that we've got to find the square numbers that go into 80. The biggest square number is 16. So that's the square root of 16 times the square root of 5. So I can simplify that. I know what the square root of 16 is. It's 4. So that's 4 lots of the square root of 5. Square root of 72. Well, the biggest square number that goes into 72 is 36. And that's 36, square root of 36 times the square root of 2. Square root of 36 is 6. So it's 6 times by the square root of 2. 343 or 49 goes into that. So that's 49, square root of 49 times the square root of 7. Square root of 49 is 7. So it's 7 lots of the square root of 7. 192, 64 goes into 192. Square root of 64 times the square root of 3. So the square root of 64 is 8 lots of the square root of 3. And finally 50, well 25 goes into 50. So that's the square root of 25 times the square root of 2, which is just 5 root 2. Okay, this is expanding brackets involving surds. And it follows the exact same rules as when we've been expanding brackets before. So multiply everything inside by what's outside. 2 lots of 5 gives me 10. And then 2 multiplied by the square root of 3 gives me 2 lots of the square root of 3. And that's positive, so it's 10 plus 2 root 3. Again here, square root of 5 times 4 gives me 4 times by the square root of 5, 4 lots of the square root of 5. And then I've got the square root of 5 times the square root of 7, which is what we did last lesson. That's the square root of 35. And again, that's positive. We're looking to simplify that square root of 35, but we can't because there's no square numbers that go into it. So we can't do anything else. We can't put them together because they're not the square root of the same number. Square root of 11 times the square root of 2 will give me 2 lots of the square root of 11. And the square root of 11 times the square root of minus 3 will give me minus the square root of 33. And again, there's nothing we can do. We can't simplify it. This is the square root of 11, this is the square root of 33, and we can't put those two things together. We could try and simplify the square root of 33, but there's nothing we can do. It won't simplify down. So we have to leave those two things separate, so we can't simplify them. Okay, so this is expanding and simplifying surds with double brackets now. And again, it's going to follow the exact same method as before. So we'll use the crabby claw method while we're doing this. So 3 times 3, first of all, leaves me with 9. Then we'll do 3 times the square root of 2, which is 3 root 2, 3 lots of the square root of 2. And then we've got the square root of 2 times 3, which again gives me another lot of the 3 root 2. And then I've got the square root of 2 times the square root of 2. And if you remember, that's just going to be 2. Or you can do square root of 2 times the square root of 2 is the square root of 4, which still gets us back to 2. And now I need to simplify that. So I've got some numbers that go together here to give me 11, and I've got 3 root 2 add 3 root 2, which gives me 6 lots of the square root of 2, which is my answer. Next one, I've not left myself much space here. Square root of 5 times the square root of 5 is first this time, and that's 5. Any square root times by itself leaves me with the whole number. And square root of 5 times 2 gives me 2 lots of the square root of 5. Minus 2 times the square root of 5 gives me minus 2 lots of the square root of 5. And minus 2 times 2 on the end leaves me with minus 4. Now I'm just going to simplify all that together. These two bits will cancel each other out, and I've got 5 minus 4, leaving me with the answer after all that work is just 1. You should have been able to spot, and that's the difference of two squares there. So you should have known that that was going to cancel anyway. So, first terms, square root of 3 times the square root of 7, slightly different this time because they're not the same surd, so that's just the square root of 21. And square root of 7 times minus 5 is minus 5 lots of the square root of 7. 2 times square root of 3 is 2 root 3. And then we've got 2 times minus 5, which is minus 10. Now, we can't simplify anything here. Square root of 21 can't be simplified down into the form a root b. And I can't put any of these things together since they're not the square root of the same number. So that's all we can do with that. There's nothing more we can do with the question. So we've got to leave it like that. Final one, and you can have a go at some of these. Expand this lot. So first of all, I need to write it out properly. If it's all squared, it's been multiplied by itself. So that's 2 minus the square root of pi multiplied by 2 minus the square root of pi. So let's expand all that out. 2 times 2 on the front will give me 4, and 2 times minus pi will leave me with minus 2 root pi. Minus the square root of pi times 2 leaves me with another lot of minus 2 root pi. And then on the end, minus the square root of pi times by minus the square root of pi leaves me with just pi. So again, we need to try and collect them together where we can. There's only one of those terms that's just got a number on it, which is the first one, so we're still going to have 4. We've got minus 2 lots of the square root of pi, take away another 2 lots of the square root of pi, which is minus 4 lots of the square root of pi, and we've still got pi on itself, on its own at the end. Can you have a go at those questions I've left for you? Thank you.